And without further ado, I would like to welcome our first speaker, Ivett, who has 15 years of experience in software development and leadership, and is very passionate about these kinds of topics, especially this one today. I won't take up any more of her time, so give a round of applause for Ivett.
Thank you. Hi, good morning. Do you hear me? Okay, all right. So I would like to start with a question. Are you happy? I don't hear you. A bit more. Yes, yeah, okay. I might have not have been clear about my question. Are you happy at work? Okay, we still have a few enthusiastic people. That kind of reflects on a recent study done by Stack Overflow, which asked this exact same question. Are we happy at work? Turns out that the enthusiastic group there, that's 20% of you. And those are the people who are happy at work. What about the rest? Well, that 32% is unhappy. That leaves still one group. And the official term for that is meh. So it seems like 80% of developers are not enthusiastically happy about their work. Stack Overflow also asks people, why are they not happy? Can you guess the number one reason? It turns out to be bad code quality. So we obviously care about code quality, but isn't that supposed to get better? I mean, now we are not even, the developers are not even writing all of the code. According to the CEO of Google, 25% of all code is written by AI. That sounds great and scary at the same time, but then I started thinking, what does 25% of code look like? I mean, if I take a function like this, that's about 5 lines of this. Autocomplete can write that. So yeah, maybe that AI thing isn't that helpful, or is it? I'm not against AI, just to be clear, and I'm going to talk about how I use it. But I want to call your attention to one thing. This is a reality check. There was another study done, and they looked at code quality in teams that are extensively using AI assistants. They found that 75% of their code is rewritten within 2 weeks. 75% within 2 weeks. Now I understand that 20% figure from Google, right? That means that 75% of the code had to be rewritten by a human. I don't know a single junior engineer who writes that bad code. So that's one thing. Then we have up to 39% year-on-year churn. That's 39% of your code that you wrote, used, and then decided to delete within a year. Then we have, that's like the difference is rewritten, is the functionality is still there, it's just being refactored. The 39% year-on-year churn, that's code that was completely deleted without being replaced. 25% more duplication in code base. Now, those of you who are more experienced in this industry, you know that more duplication isn't going to be great, right? Because that's code that's harder to maintain. And then this is the scariest one. 41% increase in failure rates. This is production failure rate. That means that our users are getting 41% more errors that they shouldn't be seeing. So maybe this whole AI thing isn't as great, is it? And we basically have a code quality crisis. And you know who is not going to solve that? AI. Because what we see is that the code quality, or the quality of AI responses haven't been really improving in the last year anymore. And the first time I talked at HeapCon, I was actually talking about deep learning. And that was many years ago. And even then, I kind of predicted a lot of the things that actually happened. But the point I want to make is that these things tend to happen in like bigger steps. Like there is always a jump and then a flattening out of the curve for a while. And I think this is what's happening now. I don't know when the next jump is going to happen. But for now, I think that's what we got, and we need to live with that. Okay, so then here is this code quality crisis, and at the same time, there is Joel Spolsky, who wrote about Netscape, how Netscape lost market share against Microsoft. They did it by making the single worst strategy mistake that any software company can make. They decided to rewrite the code from scratch. Now, I'm not going to mention that Microsoft might have done other things to help Netscape lose market share, and that Joel Spolsky was working at Microsoft at the time. These are irrelevant. The point that I want to make is that there are a lot of people who quite legitimately say that rewriting software is risky. So what's my plan with this talk? Because engineers often want to rewrite code, they want to refactor code, and at the same time, they will probably meet managers who are telling them that, no, that's not a good idea. We are experienced engineers, or we are just business people who follow Joel Spolsky, and we know that it's not a good idea. So what I want to do is first look at the reasons against rewrites. Why do we consider rewrites a bad idea? And then I'm going to show you a couple of case studies of rewrites where companies still ended up doing successful rewrites. And then the final part of the talk is going to be understanding what those companies did differently and how you can, like I systematize it for you, and I'm going to tell you how you can do a successful rewrite. And then the answer, how we convince the business, is going to be obvious. Okay, so let's get started. Why do we consider rewrites a bad idea at all? Well, it comes back to this design stamina hypothesis. To be clear, this is pseudoscience, okay? This is a feel for what we understand of software, but this is something that a lot of engineers will agree with, and it's a useful tool for explaining the problem. So we have investment over time and cumulative features, and the hypothesis says that if you do no design, then at first your feature count will be it will be really easy to add new features, but because you don't have good design, you will slow down, and eventually you might even grind to a halt. Okay, so the other curve is, oh, I'm going to start with doing really great design. I'm going to spend weeks and weeks and months designing my system, but in return, I will be so much faster later. Okay? So this is the hypothesis. Now, here's the problem with this. We all want to be on the good design curve, right? But there is a design payoff line that we need to talk about, and that is the amount of features that you need to implement for design to pay off. Okay? Here's my bad news. There is another important line, which is the minimum viable product. Minimum viable product is the smallest thing that you can build to test if your product is actually something that users want. Okay? So this is the smallest amount of stuff you need to build. Turns out that in most cases, not in all cases, but in most cases, that minimum viable product is way below the design payoff line, which means that if you are being a reckless script kiddie and you just hack away, you are reducing the investment risk, the initial investment risk for the company. And that is exactly why every single successful company has legacy code, because that's how successful companies start, just hacking away. That's not great, but what's the solution? Well, the idea would be is that we go to the minimum viable product not doing design, then we slow down a bit, we refactor, clean up the code base, and then we kind of get something close to the ideal curve. And then you might ask, okay, isn't that a rewrite? And no, not necessarily. If you are lucky and catch this in time, then you might be able to do small refactors and clean up the code base as you go without even mentioning it to anyone. You just notice that the design here is not great. You spend like half an hour fixing it, and then another 15 minutes to make the change that you originally wanted. This is a mantra that Kent Beck talks about. Make the change easy, then make the easy change. And that's a really good mantra. Make the change easy, and then make the easy change. And that works really well if you start this early. Problem is that you don't always start early. And what you do then? And what I want to do before I go further is I want to replace the cumulative features axis. I want to replace it with product attractiveness. Because the original version by Martin Fowler has this cumulative features, but it's not what really matters, right? What really matters is if people like our product better or not. And this is something I learned while running some of these Lean Poker events. This is an event where I get together engineers in the same room, and they get to play poker, but not against each other, but they program bots that are playing poker. And the reason I created this is because I wanted to show people how they act differently when they actually feel the pressure from wanting to win. And it's basically a small-scale simulation of what it feels like working at a company. And because it's a small-scale simulation, you get much faster feedback, right? In a day, you will experience things that you would otherwise experience through years. So that's why I do them. And the reason I bring this up is because this is how a Lean Poker dashboard looks like by the end, right? We have all these teams, and then they are collecting or losing points as we go. Yeah, one important detail that I missed. The bots are playing before you even touch the code, okay? So we get together, we create the team, bots start playing, and that's when you check out the code from GitHub. So you basically, while the bots are playing, you are making changes, and these black dots are people deploying their new versions. And what I want to point out is how these curves change, right? When a team is better at poker than the other team, even though they are all pretty bad at poker, like you could beat any of these, even if you don't know poker, you could beat any of these bots. But because they are slightly better than the other team, they are gaining market share, right? So what really matters is, it's not how good your product is, it's how much better it is than the competition. And this is something really important to keep in mind for what's to come. Because let's assume that we have our product. We decide to do a rewrite. And during the rewrite, we are not releasing new features. We just flatten it out. We are doing the design. After that, we will be much faster. But for now, we are just not doing any new features. We are not making our product more attractive. What happens then? Our competition comes and takes us over. And while we were here, although we were just slightly better than the competition, we were gaining users, we were gaining market share. Once after they cross over and they are more attractive, they are taking users away from us. And any single responsible CEO will shut down the rewrite at this point, because they know that if that happens, the company is doomed. Okay? So this is something that we need to understand about rewrites, the risk of rewrites. And all we did was lose time, right? We still have that horrible code base, but now we also spent a bit of time, and now we are behind the competition. We are essentially losing. So what is the implicit assumption in this nightmare scenario? Because there are implicit assumptions here. And I'm not going to tell you now. The reason I'm not going to tell you now, because I will show you case studies of successful rewrites, and I want you to spot the difference. So going forward, I will list 6 examples, and while I'm telling you these examples, think about what is different from the nightmare scenario that I painted. So first story, the abandoned platform. There is this presentation software. They build their first version in ActionScript. Now, ActionScript is something that got shut down. It was still Steve Jobs who said that it's not going to be available on Apple products at some point. And because it got shut down, this company was in trouble. Their only product was in ActionScript. So they needed to rewrite. And they tried to rewrite the whole thing in JavaScript. That didn't work. But then they did something slightly different because they couldn't make it compatible. They created a new product, and they said, OK, business users are not going to get ActionScript sooner than private users. Like, if you were just doing this on your home computer, you could install ActionScript for quite some time, but businesses already didn't allow people to install it anymore. So they were like, OK, we can build a product for businesses only. And that's what they did. It was called PresiNext. And what they did was to build a simpler product that didn't have as many features, but it was actually priced higher, and it was in JavaScript. So that's what they did. And eventually, they got to a point where the new product was as good as the old, or even better. And then they told their old users to migrate over manually because they couldn't solve, partly manually, partly automated, because they couldn't do a completely automated migration. OK, so that's the first story. Second story, catastrophic failure. I was working with a system that was basically a workflow engine. You could set up a bunch of actions, and then we would execute those actions. This was push marketing, so it would send you emails and stuff like that. What happened was when we started to move from a monolith to microservices, we didn't really anticipate what would happen with error handling. And we started to have really catastrophic errors, namely, so we at some point should have sent a coupon, like a really high-value coupon, to about 20 users. But because of this error, it got sent to everyone except that 20 users. So that client wasn't very happy. And what we did there is we said, OK, so this has to be fixed as soon as possible. What can we do about it? And what we did is we did a bit of risk analysis, and we started by fixing the error handling in the place that was most likely to cause catastrophic problems or really expensive problems. And then we went through and fixed it everywhere, one by one, until we solved everything. But this involved significant rethinking of how we handle errors. We had to move from a transactional approach, where we have a transaction database, to a distributed transaction called a Zaga pattern. And I have another talk about that. I'm not going to go into details, but it's a really interesting topic if you are using microservices, look into Zaga patterns. So that was the next one. Slow import. We had an import that was running. It was a daily import. It was running for 25 hours. That doesn't sound like a daily import. There is one day when it is. You know when it is a daily import? Yeah, daylight saving time, exactly. So once a year it was a daily import, but otherwise not. So we needed to fix this. And what we did is we looked at all of the users. Turned out that the user that had this 25-hour import, they had a very specific set of settings. Now, there were a ton of different possible ways to set up this import. That this user had a very standard way of it. So what we did, we implemented a brand new import service that was completely independent of the old one and could only handle this one single case. We did that in a week. We deployed it the next week. So in 2 weeks, this customer's problem was solved, because what we did is we added a little router at the beginning, and it would look at the import settings. It would say, is it the one that the new one can handle? Yes, then do it with that. No, then do it with the old one. So now we had two import systems, one new one that was fast, but only could handle specific cases, and an old one that could handle anything, but was slow. And then what we did, we one by one implemented all of the settings in the new import. And it eventually would have the new import do everything. Okay, that's the third story. Fourth story, becoming a platform. We have a large system. We are becoming quite popular, and we are not able to keep up with user needs. So we want an API so that third-party developers can add new features. CTO comes to the team. He says, "Okay, we need this API. Can we just? You are working with microservices. Can we just expose the microservice APIs?" And people were, "Are you crazy? Like that would be dangerous." And not to mention that I'm not gonna show people this API like it's looking horrible. Okay, then what do we do? And the solution there was to rewrite just the API part, and we do it endpoint by endpoint. So we basically took the endpoint that would be most useful for the user, and we exposed it while refactoring how it works. And we also refactored our systems to use the new endpoint. And one by one, we moved the endpoints to the new API. Okay? Who is using VS Code? Few of you. Okay. So the interesting thing about VS Code, when it came out, I was already a web developer at the time. When it came out, my reaction was, what? Microsoft is building something for web developers? We hate Microsoft. Why do they do that? And we did hate Microsoft. I mean, Internet Explorer was just unacceptable. Sorry. But Microsoft recognized that there is a huge community of developers who really don't like them and would never use Visual Studio because it was a bloated, well, it was a junk drawer, basically. And they did something interesting. They decided to create a brand new product that was competing against their existing product, was much simpler, and was aimed at web developers. It was aimed at the very demographic that hated their guts. And by now, I don't know if anyone is still using Visual Studio. VS Code basically replaced it in most markets. So that's also a very interesting example. And then finally, this is a new one. I mentioned Limpoker, right? What I did was to rewrite the whole front end just for this talk. Why did I do that? The reason is, well, twofold. One, the original version of Limpoker's front end was written in vanilla JavaScript. It was messy 2,000-line JavaScript, or more like 4,000-line JavaScript code, and I wasn't able to modify it anymore because it was so messy. And I decided, okay, now that this is my primary business, I need to fix this. And the way I did it is I just rewrote the front end, and I did something that I never did before, and that was using an AI assistant to do it. And here is the interesting part. I was talking a lot of bad things about AI assistants before, right? But when you use it responsibly, it can be very useful. So one of the things that I noticed is that when I had a clear design in mind, and I explained that design to the assistant, and when I even showed existing code to it and said, okay, this is vanilla JavaScript code for this problem, create the React version, it could do a decent job. I'm not going to say that I didn't have to modify what it created, but it was enough of a head start for me that that code base that I was writing for over a decade at that point, I could re-implement it in less than a month, which is crazy if you think about it. So that was also an interesting point, and the thing that I did there was I didn't rewrite the whole thing. Maybe if I go, I don't think I put, yeah, I need to go back a bit. I should add, so what I did was I didn't re-implement this whole thing. First, I just re-implemented this part. and then the chart, and then there are like these cards can be opened, and then you have a bunch of data there and a bunch of functions there. And what I did was to do it step by step, and I always integrated it with the old one. So for a while, you would have this part in an iframe inside the old app. And that allowed me to actually use the new features while I was implementing. And the other important thing is that the old version, you had to refresh to get new data. The new version, that's reactive. And whenever there are new games running, the points and the charts, everything gets automatically updated. So these were a bunch of things that I did differently. Okay. So what are the takeaways? What were the assumptions in the original nightmare scenario that were not in these case studies? Any ideas? Any suggestions? Yeah? Yeah, exactly. That's one of the things. Doing it all at once and not releasing part of it. That was one. And what was the other thing? Okay. All right, I'm going to tell you. So during the rewrite, we don't deliver value to the business. That's the other one. Because if you remember that chart, I said, okay, when we start the rewrite, it becomes flat. And that doesn't have to be that way. You might have a way to deliver value with the rewrite itself. So that's one assumption. The other assumption is the rewrite is an all or nothing project. Unless we finish it, it's not delivering value to us either. Okay? And basically, to do this, there are two broad strategies. The first strategy, so how do we set the refactor? The answer is, preferably don't even mention it. You just create a roadmap, like use the existing feature requests and figure out how you can implement those while doing the rewrite. Implement the new features in a new service, and then integrate it with the rest of the system, or something like that, right? But if you really must, then you should at least explain how it delivers value to the users, and how you are making sure that every step of the way we are getting there. Well, okay, let me restart. One is you make sure that you explain what the user value are we delivering with the rewrite. And the other thing is that you do it incrementally, and that allows you to show the business on a weekly or sprintly basis that you are actually making progress towards the better, faster work and all that. Okay, so and this ties in neatly with the first principle of the Agile Manifesto, which is our highest priority is to satisfy the customer through early and continuous delivery of valuable software. As long as you adhere to that with your rewrite, you are going to be good. Okay? So, but then how do you do that? And there are basically two broad strategies. The first strategy is creating your own competition. So what did Prezi do? They created a new product that was aimed at businesses. VS Code, they created a new IDE that was aimed at the demographic that hated their guts, right? They found a new market for their product. And me, when I was rewriting the Limpoker frontend, I created a reactive, much more modern competition to my existing system. And you could still switch back to the old version just until I was sure that the new one is working. But basically, it was a significantly better product. Okay? The other option is incremental replace with user value. This is the first case with the catastrophic error. User value was stability. We made the product more stable and more reliable. The second story was performance. We basically enabled people importing their data much quicker. And actually, that 25-hour import I mentioned, it got down to 5 minutes. It's a huge difference. That is something the user actually feels, right? And then there was the API basically we added the option for like the ability to extend our platform from the outside. And that is also regularly replaced with user value. Okay. Just finally wrapping up, this is my hypothesis. This is the rewrite quadrant hypothesis. And what I want to show you is that on one axis we have no customer value and clear customer value. On the other axis we have an all or nothing project or incremental delivery. And this is what I postulate. If you have all or nothing project with no customer value, this is the one everyone talks about. Like, here is our attention, because everyone is afraid of this kind of rewrite. And I say you should avoid that rewrite. Never do that, because it's gonna hurt you. The other corner is usually successful. This is incremental delivery with clear customer value. This is basically the thing that you can do without ever telling your manager, because you are adding new customer value and you are silently doing the rewrite in the back end, okay? And then you have two other options. One is incremental delivery with no customer value, which is, might be successful. One very specific example I know about is Shopify had a rewrite like that. The way they did it is they had a couple of metrics around complexity that were in their cafeteria, and people could see which team is doing how much work with cleaning that complexity up. And that was kind of a competition within the company to beat each other at cleaning up the code. It was success, but I think this is a bit less, like I would prefer to have the clear customer value. But if you have a good gamification around it, this could work. And then all or nothing with customer value, very likely to fail. Even if you have customer value, if your project is all or nothing, what's going to happen is that at some point business will start asking, why don't we implement this in the legacy system? Because we need this feature ASAP. So even if you have clear customer value, this project is likely to fail. Okay? All right. Last word on coding assistance. Here's the thing. I think that people are a bit too optimistic about what these systems are capable of. But they are nonetheless useful, and they are extremely useful when doing rewrites, because then you have something to work from, you have a clear vision for where you want to take your design. So coding assistants can be good, and they are also very good at translating code from one language to the other. Canback right now is a company that is translating Fortran code to Java and to C++, which is a really interesting concept, right? Because right now, we have all that COBOL and Fortran code that is still around there, and we want to replace, and this is actually opening the door for that. So don't get me wrong, coding assistants are useful. But what they essentially do is let you skip the part where you look in Stack Overflow and then adapt the code to your context. That's the best it can do. Okay, so use it accordingly, and whatever output you get, check it, really check it, because that's how we end up with production errors. All right, that's my talk, and I just want to mention two more things. I have a YouTube channel called Next Increment. If you enjoyed this talk, basically that's what I do there. And I also have this workshop that I mentioned. For both of those, you have a QR code there. The workshop there will be a public online event in January. Sales are on, tickets are audience sales. So if you want to come, join. It's an online event. So yeah, that's it. Thank you so much.
Thank you, Ivett. We are almost out of time, but we have time for one question. Are there any questions from the audience? If so, just raise your hand and volunteer will come with the microphone. Okay, if not, we have one question from the Huba app.
Okay.
Oh, actually, there's two.
Okay.
Okay, I'll go with the ones with the most votes. The question goes, can AI be a game changer to convince management and sell big refactor better?
Okay, so here's what you can do with so if your manager is one of these two-brain cells people and doesn't use that two-brain cells, then you can say, oh, with AI it's going to be a breeze. So you can downplay the risk of rewrites. But be very careful with this, because they will believe you for 2 weeks. After the first sprint, they will want to see results. Okay? So you can use that to get them to allow you to try it, but have a plan to actually deliver something valuable in that first sprint.
Thank you, Ed. If you have any more questions, please approach Ivett in the break.
I will be here.
Yep. We'll take a short break, and we'll be back in 15 minutes. Thank you all.
Thank you.